Assalamualaikum and good day to all. Now I will proceed for chapter 2, subtopic number 1, where we have to calculate the hydrostatic force on submerged plane surfaces, horizontal, vertical and inclined. So this subtopic is 2.3 subsection. Before this we learned that P equal to rho GH, right? Rho GH in the manometer, where we have to calculate the pressure at the level of the manometer. So now we proceed on the pressure on the surface. Okay, this is surface of the object. So pressure is defined as a force per unit area, where the pressure acts on a small area, then force exerted on that area will be F equal to P multiplied by A. Okay, so in this subsection, this is the first equation that we have to know. And as we know that P equal to rho GH. Okay, so now this equation become F equal to rho GH A area. So because we involve with the object, so we have the area. Before this, in manometer we have only the level, so we don't have any area for that level. But when we go to the object, we have the area. Okay, this is the general submerged plane, where the total hydrostatic force is the sum of all the force at different point. So it can be defined as this resultant force. So in my class, I normally use FR, resultant force, equal to PA1 plus PO2 P2 A2 until PIAI. So means that resultant force is the summing up all the force on the small element. So resultant force equal to total PA. Okay, so we sum all the force on the element. And this is the general submerged plane, where this is our plane. Okay, and we have to calculate the resultant force, this FR. Okay, react on the center of area, centroid. So center of the pressure, this is we call as CP. So the resultant force we calculate, then we have to define where the pressure act on the object, we call as CP. This is resultant force, and this here is your CP. Okay, here same equation I explained before. So resultant force equal to PA. Okay, this the same concept as in your manometer, where we consider the level only. So P equal to rho GH. Okay, so rho density of liquid, G gravity, and H equal to your height between the surface of liquid to the object, surface of the object. Okay, but when we involve with the plane or object, so we have to include the area. That's why FR equal to delta P area, this one. So FR equal to P delta P multiplied by area. So delta P equal to rho GH, so by area. So this is your equation for this subsection. Okay. Okay, this is some of the term that we have to know in this topic. Here, the general diagram where we have one plane inside the liquid. So the blue one is your liquid and this is your plane. Okay, this is your plane, your object. Okay. Okay, this is the general shape planar view in the XY plane. Okay, this is mean 3D view. Okay, this plane in 2D view. So you have to imagine how your shape in 2D or in 3D. Okay, because we have to consider the area of the object. Okay, so O is the origin at the surface free, where origin always located on the surface of the liquid. Okay, theta is the angle of the plane mixed with the free surface. So if you have to say theta, we have to consider the theta. Okay, and then y is the directed along the plane surface. So this is your y. Okay, so this is your plane and then this is your y. Okay, so this is your y. A is the area of the surface. Where is your A? Here. So means this is your area. If your object is in rectangle, so this is your area. If triangle, you have to calculate the area also. So depends on your shape of the object. So we have to know how to calculate the area. Okay, next, the A is a differential element of the surface. So if we have to calculate at the certain area only. So same goes to the F, where the force acting on the differential element. Then C is the centroid. Where is your centroid? Here is your centroid. Centroid, what mean of the centroid? Centroid mean center of the object. Okay, center of object. So centroid, C is the center of the object. Mean if you have the one circle, so this is your center. If you have rectangular, this is your center. Same goes to triangle, this is your center. So you have to know how to calculate the center. If the shape are unfamiliar, so we will give how to calculate the center in the appendix 1, the formula. Okay, C is the centroid. So then CP. CP is the center of pressure. Where is your CP? So here is your CP. Center of pressure means that where the pressure act on your surface of the object. Means that you have to calculate the resultant force, right? So when you got the value of resultant force, where the resultant force act on your object, we call as locations of pressure, where it is as CP. So different CP and also centroid. So centroid is center of object. CP is the center of the pressure. So it means that the pressure where it located or acts on. Okay, FR is the resultant force. This is your resultant force. So resultant force will act on the CP. Okay, so resultant force related with the CP. Okay, so this is your resultant force, pressure, location. Okay, here in this slide you have to understand all the term. Okay, so as we can see here, YC means that with the theta angle, the distance until to the centroid. YR means that with the theta angle until point of CP. Okay, you can see this is point of centroid, this is point of CP. So the different. So YC is related with centroid, YR is related with the CP. Okay. Okay, here is the appendix that will be given in the final or test. So it will give you the area, how to calculate the area. Okay, and we can see that here we have IXC, IXY, IXC, IXYC. So this will use in calculations of center of pressure. So where we see P, we have to calculate. So depends on the object, and we can substitute the equation by all the I here. So depends on your object. Okay. So here the resultant force that act on the submerged plane. Okay, I want to highlight here. You have to consider the plane that's touched to the surface of liquid only. Okay, so for in this case, you have to consider this plane only. So this one not involved, this one also not involved. Why? Because it not touch with the liquid anymore, so it not relate with the pressure that come from the liquid. Okay, so this is the rectangular, same last time I inform you. Okay, so we will see in the tutorial after this. Okay, here is the equation for calculation of YR, where the locations of your center will act. Okay, this is for Y coordinate. Location mean that you have to know the value of X axis and also Y axis, right? So from here you can calculate the Y axis for this calculation. This is your YR. So this equation we will obtain the value for YR, and this IXC from the table or appendix, right? Just now I show you. And this YC you have to calculate. Where is your YC? Okay. YC means that your distance with the angle until the center of object. Center object. Okay, so you have to calculate the YC until the surface of liquid. So YC means that from the surface of liquid with the angle until the center of object. That's your YC. And this area depends on the shape of your object. Shape of your object. So depends. You can calculate the area. So here you got the YR. Means that the Y axis. But for the X axis, here your equation. You also use this equation. Okay, so just focus on this one. This is your X equation for X coordinate. So this X coordinate you substitute in X here. Okay, so Y from the calculation before. So the important one is center of pressure. You have to calculate the X value, X axis, and then also Y axis. So that's your CP. Okay, this value you obtain from the appendix. YC you have to calculate by yourself. Area depends on the object. Okay, then XC also given in your appendix. Okay, so this is your procedure how to calculate the force on the rectangular wall. So FR, so you have to calculate the FR. FR equal to PA, so rho GHA. Okay, but for this case we will use H centroid. Okay, I will explain after this. Next, you have to calculate the located the center of pressure at vertical distance. So normally we calculate your YR, locations of pressure. Okay, so the last one, you have to show the resultant force acting on the center of pressure. So you have to draw the FR acting on your CP. Resultant force acting on your center of pressure. Okay, here is the example how to calculate the force on the submerged rectangular plate with the theta. Okay, now we have the angle. So first equation for this equal to FR plus rho GH centroid area. So in manometer we just use rho GH, right? But for the submerged plane we have to use rho GH centroid and also the area of the plane. Okay, so here P naught we know normally PATM. Okay, plus rho we have the value, G also we have the value. Now we have to calculate the HC. HC means that your distance from the surface of liquid to the center of object. Okay, means that center of object you have to find first. If you have rectangular, this is your rectangular, right? So this is your center. So if here B means that center equal to B over 2. So here is your center. So B over 2 distance between here to here. So this is your C. Centroid. Centroid is the center of object. So now this is your center of object. And then HC equal to center of object to the surface of liquid. Here your HC. Okay, this is your HC. So now we have to calculate the HC by the equation. So we draw the equation. This is your theta. This is your HC. This is your S, right? This is your B over 2. So you just redraw again this figure. So sin theta equal to HC over S plus B over 2, right? So you got the value for HC. HC equal to S plus B over 2 sin theta. So you got the value for the HC. And then now for the area. Area depends on your object. So for this case rectangular, so area means that A equal to, in the case this is A, so B multiplied by A, so you got the area. Then when you obtain the area and also the HC, so you substitute in the equation. So this you substitute in this equation, and then area also. Then you simplify the equation, you will get this equation. So the main thing is you know how to find your HC, and also you're not confused with the area of your object. Okay, that's all for the case number 1. Second case is the simple one. If your plane is vertical, submerged, okay, this is your plane. So we use same equation, F equal to P naught plus rho GH centroid area. So now we have to obtain the H centroid also, because we know the value for P naught. Rho G, you have the value, right? But for H centroid, we have to find from the diagram. H centroid equal to, means that H centroid, the distance between the center of object to the surface of liquid. So this is also rectangular. So the center one for sure is at the middle one, right? So at the middle, so here B over 2, right? So HC, where is your HC? HC is your distance from your center of object until surface of liquid. So this is your HC. So how to find your HC? HC equal to S plus B over 2. That's your HC. So you just substitute the HC. Okay. So area. Area also your rectangular. So just B multiply by area. By the A, not area. So this is your shape. So this is your B, this is your A. So area, wide and long, multiple by long. So you just substitute your equation in the equation, this equation number 1. So you will get this equation. Okay, this is for the vertical plate. And the last one is the horizontal plate. So same goes to the previous one. FR equal to P naught plus rho GH centroid area. So H centroid is the distance from the center of object to the surface of liquid. So center of the object here. So until surface of liquid. That's your HC. In this case, HC equal to your H, right? Same value. So you just substitute, and the area same as before. This is your shape. Okay, this is your A, this is your B. So area equal to A multiplied by B. Okay, so you just substitute your area and also your HC, and then you will get the equation FR equal to P naught plus rho GH multiplied by AB. That for the horizontal plate. So that's all for the concept for subtopic number 2. Okay, thank you.